All right, tonight we're going to be going over Intro to Java programming just enough so that when we start talking about FRC programming, more of it will make sense, and we'll definitely be able to learn a lot of it on the way as we're trying to do a lot of the things we need to get the robots actually working and programmed fully. There are some of the basics that definitely it helps to know ahead of time. If you have any programming experience at all going through this, you'll tend to see a lot of the things that are similar. So if you've done Scratch or JavaScript or Python or any of those, a lot of the same things exist here. The format and what's called the syntax is just a little bit different. It'll be different, especially from like Scratch or any of the block programming languages, because we're not dragging and dropping. We're actually typing everything out. But what the actual words are pretty similar, so it shouldn't be too unorthodox or different if you've done any amount of programming. If you've done nothing, it'll probably take a little while to get on, but this is definitely a good first step. And then as we get more into the robot side of things, you'll gradually learn more about it and understand it more. Okay, so we're going to be using JDoodle to kind of go through things just so it's nice and easy and everyone can do it inside their browser. This is the first program we're going to kind of dissect. The JDoodle links here, so you all who are following live have the spreadsheet. It'll be at the bottom of the YouTube video for people watching the recording later. And so as we're going through this, we're just going to be looking at specifically some parts of the code, walking through it, and so we get a good idea of what everything is doing. So in this first program, at the very top, we have these green lines. These are comments. Comments are the part of the program where it lets us just write and document what we're actually doing. It lets us label things, name things, and especially when we're programming with other people, like we're doing on the team, when we have multiple people programming for the competition robot, it's incredibly important to leave comments to provide that information to the other people who are going to come back in and read your code, edit the code, modify it to make it work in the future. There are definitely things in our code library that we use on the robots in 2020 and 2021 that were probably written in 2015, 2016 by students who are on the team back then, and they have just been being updated and modified for the last 5 or 6 years. So things you write, if you're writing stuff for the competition robot, and like if you may not even think it's a big deal, like we have a couple little like Xbox controller libraries and things that we wrote 4 or 5 years ago that probably didn't even take that long. It was probably a day or two of work. But because it was the right solution and because it did the thing, we have now continued to use that every year and used the modified versions of it since then. So if we didn't have those comments in there, it'd be a lot harder for us to keep using because we'd have to like relearn exactly how the code works. Where with the comments, we can just read what the intent was as the person was actually writing it. And so that's one of the big things. A lot of times you just want to explain what you're trying to do because your code doesn't always do what you're trying to do. So it's really important that you give that intent so that when somebody goes back and reads it, like, oh, this is what they meant it to do. This is what it's actually doing. Now I can figure out how to change it to make it do what the intent was. Let me zoom in a little bit. Okay. So in here, we can start seeing there's a couple different ways to do comments. So these double slashes are what we're using in this. These are single line comments. Oh. So these are single line comments. If you need to do a multi-line comment, you use slash asterisk or slash star, whatever you want to call that symbol, shift 8. And so this lets you do big paragraphs. A lot of times we'll do this at the top of a file or something so we can describe exactly what that whole chunk of code is doing. And then the single line ones are useful just to name something or say what a specific line does. So if we look in here, we can see that this creates the class. For now, think of each class like a document or a file. And so this is telling us what this line of Java is actually doing. And as we get going and we get more familiar with things, we don't necessarily need to leave comments like this on every file because there's some things that we expect people to know once they kind of understand Java, but because this is our first time introducing it to a lot of people, we may not have that same understanding, and we can't really assume that understanding, so we tried to be more deliberate with our comments. So down here we have some that tell us like these are the end, so we know what which one of these braces is it associated with. So that's helpful, so you can kind of know where they're associated or where it's going. So this is the end of the whole intro to Java class, and kind of figure things out from the comments a little bit without having to dissect the code. Okay, so we'll see more comments as we go through, and it'll help us understand things. The real main point of this first program, though, is to introduce what variables are. And variables are going to be very similar to, they're similar ideas to what you use them in math before, where you have x and y, and you're making graphs or whatever you're doing in Algebra 1 and any other math courses. But in programming, they can do a little bit more because they store information for us, which is the really important thing. So we're not really just solving for them ever. It's not just like math where they have a specific value and we're trying to solve for them. It's that we are able to assign values to them, and we can store things in them, and then we can also go look that information up later. We can modify that information, and it allows us. It's basically just where we can store things that we can then access later in the code whenever we need to get whatever the program's actually doing to actually get it accomplished. It is very important that we choose the names of the variables. They don't need to be just single letters. Most of the time they won't be. Most of the time we're going to try to give a very descriptive variable. So we might need a variable that talks about the speed of a certain motor, and you would say arm motor speed or something. Like they can be relatively long. You want the names that you assign anything in your programs to actually describe what they are. So in this case, like answer is a variable name. So that's actually describing what that variable is. It's the answer to the problem. We could have easily just named this Z, but then you don't really know its purpose, right? If it just has a generic name, if it has a made up name, if it has a funny name, it takes more work for the next person coming through, or even more, also importantly, yourself 2 or 3 months later after you've forgotten what you wrote or what you were intending to write. Having those actual useful variable names to where you know what they are and know what their purpose is very, very helpful. There are different types of variables. The 3 that we have right here are labeled int, which is short for integer. It's a type of variable. Ints store whole numbers, so we can't have decimal points. We can only have 0, 1, 2, 3, 4, anything like that. In Java, they can also be negative, so you can have negative 1, 2, 3, 4 without any problems, but it's all just counting numbers, whole numbers. You can't have decimal points with integers. Okay, so as we look at this first program, we have these semicolons at the end of every line. And in Java, every statement must end in a semicolon. The nice thing about programming is it's really, really fast to test stuff most of the time, especially testing syntax and making sure the code is complete or runnable. It doesn't necessarily mean it's going to work. It doesn't necessarily mean it's going to actually do what you intend it to do, but it's pretty easy to figure out if you've made a typing error, if you made a typo. The program, when you try to actually tell it to run, won't work very well if you don't. So if I remove one of these semicolons and I hit execute, it's going to get mad at me and tell me error expected semicolon, but it's not there. It even has a little arrow exactly where it wants me to put it. And so that's where it'll kind of remind me if you make a mistake. So things like that, you're going to have a lot of typos. After you've written a bunch of code, you'll go to try to what's called Compilot, which is basically like get it ready to be run on the robot, and you'll get a decent list of errors sometimes, and you just go through and fix them if you forgot semicolons, if you named something wrong, anything like that. It'll help you out, so you don't have to be perfect while you're programming. The computer can kind of check for you a lot of the time. So I put it back and I execute. It'll actually send me out what the answer to our problem is. 10 plus 20, our answer is 30, and that's kind of what our program does. It just tells us what the answer to that is. So yeah, so knowing that learning how to read those error messages and figuring out how to solve them is really important. Sometimes they're really easy, like this one where it just literally tells you where the semicolon should be. Other times they're going to not make a ton of sense, and sometimes you'll have to either ask somebody else if you're in the lab and there's somebody around. Maybe they know. You may have to just Google it and try to figure out what that error is. There's a lot of error messages, and a lot of times you can just paste the whole error message into Google, start reading around, and seeing what other people have had those similar situations, and you can figure out where the problem is inside your code. Okay. Basic math in Java. So the equal sign in programming doesn't necessarily, it means a certain type of equals. Like in math, there you kind of just use the same one in algebra and any other math that you normally are doing at the beginning of high school. And so but we have to kind of differentiate a couple different things, and we'll see the second type of equals in a few slides. But this first type of equals is the assignment operator. So this is telling the program that it doesn't matter what x used to be at all. We're saying that now x is assigned the value of 10, right? So maybe x had a value before, x could have been 15. It doesn't matter what x used to be in any way. X is just a place where we can store stuff. And when we use that equal sign, we're assigning a new value to that storage spot and kind of overriding or erasing whatever used to be there. The variable is always on the left, and whatever is being assigned is on the right. So in both of these cases, x is being assigned 10, y is being assigned 20, and then answer is being assigned the solution to x plus y. Other basic math can be performed with variables or with numbers, however you need to. So you have addition, like we're doing here. You have subtraction, multiplication, division. It is important to remember that, like we talked about earlier, integers can't have decimals. So if we go in and change some of these numbers and we change this to division, if the answer is actually 1/2, the program won't be able to do that because it would need a half. So it'll just give us, we can test it and actually see what it'll give us in just a second. All of these different, the actual, what's another word for operator? All of these symbols, right? Plus, minus, asterisk, slash, equal sign, all of those are specific operators that then do the function in our software or in our program. So we have assignment operator, addition operator, subtraction operator, multiplication operator, division operator. It's fine if you call them the multiply sign, addition sign, whatever. I don't think largely everyone's going to know what they are, but it's important that we know that they're operators because they're kind of special inside of our code because you couldn't do int plus sign equals 10. Java won't let you do that because the plus sign's already specifically assigned a task that it has within the code. You can't assign it a thing. You can't make it a variable. It is an operator already. So it has to serve its own purpose from the beginning. Okay, so one of the last things to look at so we can start actually playing with this program a little bit more is the print line function down here. So this last line of code, system.out.println, with these answer and quotation marks. There's like a colon and a space. And then there's another addition sign and answer here. So in Java, this whole thing is known as a method. So pretty much anything that has these parentheses at the end of it, when you have a line of, when you have what looks like, it could look like a variable, it could look like anything, but if you have a parentheses at the end, it's going to be a method. Methods are part of the program that actually perform tasks. So they're things that do stuff for us. We can send, depending on the type of method, we can send variables to the method so it can use the information inside those variables to do a thing. The specific method, system.out.print, the ln stands for line, so system.out.println, allows us to output text for us to actually read. So, which we saw down here at the bottom when it actually ran, we saw that it outputted answer :30. And so that's what this line actually does. If we don't have this, it wouldn't output anything. It would have done the addition, right? Answer would still equal 30 because we assigned it to that value. We just wouldn't see it down here because we never told it to actually output. For a couple things that are specific to this, we see that the text is in quotation marks here. So this is important. So anything, when you have text in quotation marks, it tells Java to not think of what's in there as potentially variables or methods or anything, but to think of it as what's called a string. We're going to look at that in just a little bit, but it's basically just tells it to look at it like text, like something it's going to be able to display directly as that text. So if you wanted to, you could put operators in here. You could put plus and equal signs and anything else inside of quote marks, and you can use those to actually display that information separate from the actual program that is using those for a specific task. The plus sign here ends up being a little bit different from the plus sign we used before. It's still doing addition in a way, but because it's doing it on this text object here, it's what's called a string. It converts our answer to be a string as well. So that's how it's able to actually give us this 30, because 30 is now just like if we had it basically, instead of just having this here, it would be like if we had quote 30 quote here instead. It does that conversion for us, which allows it to get that output. Okay, so I'm going to go ahead and we're going to explore this a little bit. Feel free to do it on your own program, but I'm going to go through and make a couple changes so we can see what those outputs look like. So we know we can get 30 if we do this. If we change any of these values, we should get the change in value that we expect. So now that this is 5 instead of 10, when we do the addition, we should get 25, which we do. If we start changing some of the operators, so maybe if we do subtraction, we get negative 15, which is what we expect. 5 minus 20 should be negative 15. We can do multiplication. Maybe we can do multiplication. Oh, I'm not actually clicked in. There we go. We do multiplication. We should get 100. 5 times 20 is 100. Now, when we do something like division, that's where we get different. So if we do 5 divided by 20, because we're still using integers, it gives us 0 because it can't display decimal points when we're storing the value as the integer. If we change this around though, so maybe we change this to 50 divided by 20, so now we have a little bit of a different math problem, and we execute that, we'll get 2 because 20 can fit into 50 2 times. There is some decimal points, but we don't have any of that. What if we do 10 divided by 20? We still get 0. So yeah, so no matter what we do here, we should be getting 0 if the first digit is going to be 0. Similarly, if we want to change what the text is ahead of it, or if we want to change how it's outputted, we could change any of this and we could make it look a little bit different for us. So it'll put in, maybe it will. Did I break JDoodle? What did I do to JDoodle? Hold on. Okay, that's fine. I think it just didn't execute that first time. So yeah, so we can see now that it used the equal sign instead of the colon. So anything we put in here, we can change the text and get it to output. We could have multiple lines. So if I copy this, I could paste it up here. The indentions aren't necessarily part of the program, so this is important if anybody's learning Python at the same time. The indentions don't really do anything. So if I execute this, you'll get, the code will run fine. The problem is if you don't indent cleanly, it's just much harder to read the code. So you don't need to indent everything. We could have everything just written all directly on this this level here, the same as public. It could all be written at the front, and it would run perfectly cleanly. The computer wouldn't care. However, your teammates and yourself, when you try to actually read your code, would care a lot. I would care. So we do need to make it look clean when we're doing this. So it is important to have a reasonable. Oh, what did I? Hold on a second. There we go. Maybe not. Why is it being weird today? Okay. Tabs are being weird in JDoodle for some reason, but we don't actually write our software in JDoodle. We'll use another program that I'll talk about at the end that makes this a lot easier for us. But if we wanted to change something up, if you wanted to find out what x was as well, you could paste both what x equals and what y equals, and it'll give us that information too. So we can see what x and y equal and what the answer is. So this is a good start to what we can do in Java in kind of basic just math operators and using integers as our variable. So I already went through a few of these slides. We talked about how division works. Since int can't have decimals again, the answer is 0 instead of 0.5. So to be able to actually have decimals, what we want to do is have, we want to change our variable type. Instead of using integers, we're going to use a double. So this allows you to store numbers that have decimals. So that's the biggest thing. So if we change everywhere where it says int here to double, if I change this back to a 10, if I change the addition back to division, we should see that now we get this 0.5. We also see that even the x and the y, they got a 0.0 added to the end of them because they're doubles. If I change one of them back to an integer, you can see that it displays it a little bit differently, right? It doesn't have that decimal point there because it was an integer, but the double, because the double is an answer, it was still able to do it. If I change this one back, it should still give us the same thing. Nope, so it actually didn't. So this is actually where it gets a little bit more complicated. I didn't actually plan to go into this, but I happen to, so we're going to be here. So because both of these are integers, when the program did the math, it did them as if it was an integer, and then it still tried to store the answer in the double. So it didn't do the math as if they were both doubles. It did the math as if they were both integers. So this is one of the places where it's important if you possibly need to have decimals to just use double. Most of the time with the robot, you can use double in a lot of places. We're not too worried about saving memory space or anything. Most of the time with what we're doing on the robot, that we need to be using integers. But if you do end up programming some other devices, if you're programming like smaller smaller microprocessors and smaller controllers that aren't as advanced as what we get to use in FRC, sometimes you might need to worry about how much space is actually being used, which is a much deeper topic. But at that point, then you can kind of choose between double and integer. There are times where you want to make sure you're using an integer. If you want to make sure you're only counting and you want whole numbers all the time and you never want a decimal, then you'd want to make sure you're storing everything as an integer. So that will happen on occasion. But a lot of times, if you're not sure, defaulting to double is fine, and you normally won't run into too many problems that way. Okay, we looked at strings a little bit already, but we can just go through them a little bit more. So strings are where we store text in Java. So that's where anything in those quotes are a string. So if we modify the program like we have here, we can actually store we can call string text. We can give it a name. Text would be the variable name. The variable type would be string. And then we'd be storing answer : space inside of it. So we can do string text answer colon space. Can't forget our semicolon. And then down here, we can replace this string, because we just typed it out here. We can replace it with the variable text, which we know is a string, and we've assigned answer colon space to it already. So we should get that same answer that we had before, because it's just doing that substitution for us as it's solving for whatever this variable is here, and then it's doing the same thing here and taking whatever the variable is for answer and putting it in the right place. Okay, so we've talked about different types of variables, integers, doubles, and strings so far. Talked about the assignment operator. We've talked about some of our basic math operators. What we're going to get into now is what is called Boolean logic, and some ways that we can compare things inside of our programs. And this is one of the things we do a lot. A lot of times we're checking on different states of systems. Is like if we have a robot with an elevator that can move up and down, is our elevator all the way up? Is our elevator all the way down? We need to kind of do these comparisons to check if something is happening or not. And a lot of times we use Booleans to do that. So I'm going to go ahead and close this other one. Yeah, we can go ahead and leave it. Okay. So Spectrum's second program. So we have some more comments over here. We're going to go through and kind of see what this program does for us. So looking at the program from the beginning, we can see what the actual output is. So let me go ahead and execute it. And so we have some strings in here, right? We're using that print statement again to give us six different outputs or lines of text as our output. But what we have over in where we had the variables before, and we were just getting those variables, we have some different operators that we haven't seen before. So we have this double ampersand, we have this double pipe or bar. I don't actually, it depends on what you want to call it, but shift slash above your enter key is how you get to that one. And we also have an exclamation point here. These ones will look a little bit more familiar from math. We have our less than and our greater than signs. And then we also have two equal signs next to each other, which we'll also look at. So we can see sort of how some of these things affect what we're doing. So from the beginning here, we have B1 with the double ampersand. So this is going to be called AND. So we have B1 and B2. And so it comes out as false. We have B1 or B2, and this comes out as true. And then we have this exclamation point, which we're going to call not. And so we have not B1, and that comes out as false. So if we go up in here and we change something, so maybe we change B2 to true, we can execute that, and we can see now that we have B1 and B2 is true. B1 or B2 is also true, and not B1 is still false. If we flip a couple of these again, so instead we can flip B1, we can change this to false. We'll get a little bit different results. Right now we have B1 and B2 is false. B1 or B2 is true still, so that's been true all three times. And then not B1 is true for the first time here. If we make them both false, we'll get our last combination of outputs for these top three. So we can get B1 and B2 is still false. B1 or B2 is false now. And then not B1 has stayed true from the last one that we just changed up. X and Y can also change values a little bit too. So we have this X less than Y, X greater than Y, and X equal Y. So if we look at it right now, it says X less than Y is true. And so we can tell that is true. So 20 is greater than 10, so we know 10 is less than 20. And so we have our true statement as 10 is less than 20. Here we get a false statement because 10 is not greater than 20, so we get a false statement. And then this bottom double equals, is what is known as the comparison equals, right? So it's basically not assigning the value. If we just had a single equal sign, we'd be assigning the value of y to x, which is not what we want to do. Here we want to check, does x equal the value of y? So we use two equals to do that comparison for us. So x equal y is false here. If we go up and change some of these values, if we make this say 30, not 130, if we make this 30 and then execute, we can see these flipped around. So x is less than y is false because 30 is not less than 20. X greater than y is true because 30 is greater than 20. And then 30 still doesn't equal y, so that's still false. Or it doesn't equal 20, so that's still false. If we change this to 20, we should get slightly different results, right? So now both of the greater than or less than are false because they're equal to each other. So it's not either greater or less than, it is directly equal to. We can, and as in our comments say, there's a couple other comparisons as well. So we have less than or equal to. So we can use that symbol right there to do less than or equal to. We also have greater than or equal to. And we also have not equal to. So if we change up some of those, they should do basically what you expect. So if we do not equal to, we do here. If we execute that right now, we'll see, I didn't change them here. That makes it confusing. We need to change it in our string as well to make it a little less confusing. We see that x less than or equal to y is true because it is equal to. X greater than or equal to y is true. And then x not equal to y is false. And then if we go in and change any of these, if we change it back to like what we had to 10 and 20, we should see the exact outputs that we expect, just like if we were in math class. So x is less than or equal to y, so we get true. It's not greater than y, so we get false. And it is not equal to y, so we get true. All right, so I think, yeah, so some of this is going to talk more specifically about how these operators work and what they do. So anytime where we have this true or false outcome and something can be true or false, what we're working with are called Booleans. And we're working with Boolean logic, whether something is true or false and how you can combine items that only have those two states. They're either true or false. And we have operators that are called logic operators that allow us to compare them and combine them to get the various outputs. And that's kind of what we were just doing as we were playing with the different ands and ors and nots. So again, Booleans can only ever have two things. They can either be true or they can be false. There's no other option. They can't be 0, they can't be 1, they can be true, and they can be false. In Java, it's important they're always lowercase. So it's just lowercase true or lowercase false. Nice and easy. You can't assign them T, you can't assign them F. You have to actually write out true and write out false. We talked about these operators already, but it's definitely important to know what they are and to make sure that we remember to double up on them. So it's the double ampersand for and, the double vertical bar or pipe for or, and the exclamation point for not. And then these tables down here are known as truth tables. So these basically can tell us, given a certain input, what we expect the output to be. So not's one of the easiest ones, right? So if we know if something is false, if A is false, we know not A is true. If A is true, we know not A is false. And and or are a little bit different. So and requires both A and B to be true for its output to be true. So the only one of these options that comes out as true is the bottom one where both A and B are true. The other three potential options here are all false. Or only requires one of them to be true. And so in this case, the only false one is the one where they're both false. There are definitely some more complicated logic operators. We normally don't use them too often in Robot, so I'm not going to go into them here. You definitely would if you're taking a full intro to Java class. But that's not what this is. This is just going to get everybody's feet wet a little bit. Okay, so comparison operators are what we were checking on this bottom part of this program. So they're different in logic operators is that they don't work on Boolean values, because it doesn't really make sense to ask is true less than false, right? That doesn't really make sense. So these comparison operators work on, normally when we're using them, we're just going to be working on numbers or something that can at least be counted in some way or have a value associated with it, right? And so these are all the ones we kind of already went over. It is important to remember that double equals is the comparison equals and not the assignment operator. That is one of the easiest things to get backwards, especially when you're first starting out in programming. That when you're checking if something is equal to something else, you have to use double equals. And when you're trying to tell something to now have that value, you use single equals. Not equals is going to be the same. Anytime we use that exclamation point, we know we're just kind of flipping its value. So it's going to return true anytime that the two sides aren't equal. And then the other four operators are going to be very, very similar to what you've learned in your math classes. And again, just seriously remember the difference between equals and double equals, the assignment operator and the equals comparison. At some point, like even every once in a while, I still forget it and mess it up when I'm writing something because you're kind of going fast. You just hit equals thinking it's the right one, and you realize you messed it up. But normally you can figure it out pretty quickly when you try to actually run the program and realize that's not doing what you expected it to. Okay. Third program. So now we're going to look at some of our logic as we go through the code a little bit. So we've talked about our math operators, we talked about our logic operators and our comparison operators. But now we have to actually start letting the program do a little bit more so it can actually, it can be checking on things, it can change its output based on some of these values. And that's really when programming starts getting powerful, is when you can start having a lot more of these control structures involved than always just getting the right answer like we were doing before, right? Like at that point, we were, it was basically kind of like a calculator. A couple times it was giving us specific things, but we weren't able to actually change things or kind of change what the output was based on different conditions or anything like that. So these control operators will let us do a lot more of that. This is where we're going to get into if, the if statement and the else statement. I don't know why that decided to be weird. Okay, so the first output of this program, so we'll go through it in a little bit, but it's important to see what we get here. B1 is true, B1 and B2 is false, and X is less than Y. So that's what our initial sort of statements are. And you could tell it would be tricky to have those come out as our outputs if we were just if we wanted to actually have these text outputs like this. It would be tricky to do that if we were just using the same program we had before, because we can't really switch which ones we're outputting, right? We were outputting all 6 of these things. Some of them were true or false, and you could change the true or false pretty easily, but you couldn't change this inside text very easily. So this program lets us do that using our if and else statements. I don't think we need to go through this too much. Okay, so if, else if, and else. So these, like I said, these are kind of control statements. They let us control the flow of the program. They allow us to have certain parts of the program run under certain conditions and other parts of the program run under other conditions, which is very, very helpful, especially in what we're doing for robots. We use if and else statements all the time. So our the basic idea here is that the if statement is going to always be checking it's going to be checking for a Boolean. So whatever's inside these parentheses has to come back as true or false, right? Because you need to say, if true, do something, if false, do something else. If I just say if 1 or if 2 or if some other number or if string answer, right? Any of those don't really make sense. That question, it doesn't have a true or false. It doesn't have a way to get back a answer very easily. So you need to use, a lot of times we're using those comparisons in some way, or we're using one of the other Boolean operators to get to to get whatever's in here down to a single true or false statement, so that the if can decide whether to run the true thing or to run what we tell it to if the answer is true, or run what we tell it to if the answer is false. Okay, so the basic structure after we have this Boolean here, or something that's going to return a Boolean value, going to return that true or false, is if it is true, it's going to do whatever is inside of these braces. So if x is equal to y, it's going to print out x is equal to y. Then it's going to finish off this statement and say, okay, so what do I do next? So then it says else if. So this else is really important because else only gets run if this is false. So if x is actually equal to y, the program doesn't even look at the rest of this code because it knows that this was not false. So it just skips right on down and starts running the code below it because it knows it's finished now. This was true. I don't need to worry about else. If this is false, then it comes to the else statement and says, hey, this if statement was false. You're next. What are we doing? And then with this else, we have another if here. So it has another thing to check. So we can say, hey, is x greater than y? If it is, it can print out this nice statement for us. And if it is, it'll print out the statement. And then because we have this other else attached to this if, we know that we're just done because this wasn't false. So we can be finished and we can keep running other code. But if both of these are false, and we've kind of gone down this tree as we're waiting for a true, right? We're waiting for something to actually do. This is false, so we don't do this line. This one's false, so we don't do this line. Then we get to this else, and it doesn't have anything to check. So it basically says, you've gotten this far, this is what you're doing. So it doesn't have an if here to check it. So this is always going to run if both of these are false. Or actually, as long as this one is false, but it has to like get to this one first, right? So if this one was true, it would never even check this if. This would never even run. But this is kind of the last case scenario. Is just if everything else was false, do the last thing in your else statements. So we can see exactly how this runs. If we were to go up here and change it to where we had maybe B2 was true. So instead of it saying B1 and B2 is false, we could make it flip over to true. So if B1 and B2, so if true and true, it's going to print this now, and it'll just never print the is false. So we can go ahead and execute that. And we can see that it is true. And it never even saw this line. So this is only ever going to print 3 lines because we have these 3 if-else structures here. If I change B1 to be false, now because this doesn't have an else statement at all, nothing's going to get printed from this first statement, right? Because if B1 is false, that means this line doesn't get printed. And so it just moves down with the rest of the program. And so we should only see 2 outputs here because we got nothing from this first one. And then we flipped this one back because now B1 is false. So now we have if false and true, which we know false and true results in false. So that means it's returning this bottom line. And it's going to print out this for us. And down here on the bottom, we have the else if. So we have the if, else if, and else. And we can look and see how these are carrying on. So right now it has x less than y because 20 is less than, or 10 is less than 20, excuse me. If we flip this to 20, we should get the equals because we know that 20 is equal to 20. So we'll get this first line and it'll ignore all the rest of this. So we get that equals. And then if we were to change this up to 30, we can get the last output, which is x is greater than y, is the last one we hadn't seen. So it'll stop right here. And since this is true, again, it just skips over this last else and continues on with the program. Okay, I think we're coming up towards the end here. I'm going to try to make sure we get finished with everything. We shouldn't need these. Okay, 4th program. So fourth program, we're going to actually look at a bit more into what are called methods. So we talked about how this print line thing is a method, so it allows us to do something in our code. We need, we can, a lot of times what we're doing is we're creating our own methods that allow us to take in variables, possibly multiple variables, do something with them, check what values they are, and then figure out what output we need to do. So in this program, we have an add for method. So it just takes a number and it has an addition 4 and it returns that number. We'll talk about this structure in just a second. And then here we have an if true print. So it takes in a Boolean that we named bool, B-O-L. And then it also takes in a double, which is named num. And it's a pretty simple program. It just says if bool. So if the Boolean is true, go ahead and print it out. If it's false, just go ahead and finish. So if bool is true, do our system.println or system.out.println and print the number for us. Inside our main, so this is still the first thing that gets called, this main method. This is getting called whenever we click this execute button. So we have to, inside of here, tell it to call these other methods. So in this case, we have a call for add 4 right here. So this is taking x and adding 4 to it, and then it's going to print out whatever add 4 returns. So this return method here and this double up here allows us to know what is actually being sent back from the method, like back to our main program. In this method, because we have void here, it means nothing is actually being sent back. It can do stuff inside the method, which is what this print line does. It's actually doing something and putting something out to our results page down here. But no, it's not actually getting a value back. So if you tried to if you did 1 plus if true print, it wouldn't make any sense because this is not returning a value. So if you try to add 1 to what is basically what's called void, it doesn't really work for us. So we can see the results here. And so we get a system.out.println add 4 to 10, and we get 14. So that's what we were expecting. And then here, since we have these two statements here, if B1 is true, print X. If B1 is not true, print Y. Since B1 was true, we see it print X, which is 10. If we flip it, maybe we make this false, we'll see that it should print Y now. And so it's going to go ahead and print 20 because this is false, and now we're printing, and so not false is true, and so that's going to allow it to print our Y value, which is 20. Okay, so we explored this already. There are a few key kind of patterns you have to follow when making a method, and that's one of the big things we do when we're programming anyways. A lot of times we don't have to know exactly word for word what we want to type and what characters need to go in exactly each spot. A lot of times you're going to be kind of looking at other bits of the code that already exists for our robot and other things that other people have written. And a lot of what you're going to be doing is kind of matching up those patterns of how the texts work and kind of what they're accomplishing, kind of copying it, editing it to serve the purpose you want. And a lot of what's the really important skill eventually is kind of knowing where to do those edits. So things like, for now, just knowing that public static helps the program work. You don't really need to know what public static is. If you wanted to make another method, you could probably follow this pattern and do it without ever knowing exactly why we type public here or exactly why we type static here. You could just copy these two things, decide whether you wanted void or double or int. When you can kind of figure out that just any variable goes here, right? We have double here. So you could put a string there. Any of those other things that can be considered variables. And then you can figure out that this is just the name, so you could type out whatever you wanted to call it. And then you could follow this same pattern for as ever many, we call these arguments. So these are things that are going to be passed to the method. So you could copy double, you could change its name, because name is just kind of how we refer to it down here. We're just giving it a variable name. We could have it's pretty easy to solve the pattern if we need a third argument in this. We know we just do a comma and a space, and we can add a third argument. So a lot of it is just figuring out kind of what the patterns are from code that is working, and building that up, kind of testing things sometimes. You're not always going to get it right, but it's one of the really nice things about programming is anytime you test or try something, you're rarely taking away resources other than time. So it's totally okay to just try stuff. You're not like you're using up material or something if you were actually building something to try it. Most of the time you're just using time, maybe some battery power on the robot or something, but that's basically free. So it's not really important to know a lot of times specifics of why things work. And if you're interested and want to investigate, it's super easy just to type some of this into Google, be like, ask what is public static, and there's certain to be tons of pages that come up. There's a lot of people who program, and a lot of people who write documentation for it. But you don't actually need to know a lot of the time. You just need to be able to kind of solve for those patterns and get it to actually work for what we're doing. The next value is that return value that we already talked about, which can be any variable. Void is used when we don't send data back. And then, like I said, you can return any type of variable that you want, Boolean, string. There's some other things too that we'll get into as we move forward. Parameters, yeah, so add fork has the parameter num. And you're required to give that variable. So if you just typed add for parentheses and didn't have anything in it, it wouldn't make sense. So if we just had like add for here without the x, because we asked for a num here, if we try to run this, it's not gonna work because we can't have no arguments, right? So it said it found no arguments, but it requires a double. So it's just not going to run this program because we didn't meet the requirements that we set up for it. Okay. Return is the keyword that tells it which data to send back, right? So that's that return right here. I shouldn't have capitalized it there. I apologize. So return here tells it to send this solution back as this double. So in this program, wherever add for is will be replaced by whatever we put to the right of return. So in this case, when we have x here, it's x, which is 10. So this x gets replaced by 10. 10 gets sent to add 4 as num. Num gets replaced by 10. We do 10 plus 4, we get 14. And 14 is what's sent back in here and is what's printed when we execute this. We get 14. We already talked about that. Okay. So, yes, that's the basics of methods. And then we can start looking at things that look a little bit more like robot code. So in this last example, I believe this is the last thing we're looking at, is we're going to start looking at how, what an actual class is. And so this is where things get a little bit more complicated and a little bit more specific to Java. So this might be a little bit different if you've had experience with other programming languages. Some of them have classes, not all of them. But classes allow us to create a space that kind of allows us to duplicate a lot of stuff for us. So in this case, we're going to have something called a motor class. In JDoodle, it's not going to do anything because we're not attaching to a robot, but we're going to have a similar thing on our actual robot code. And we can imagine that if we wanted to have a bunch of useful variables and useful methods that all attach to a motor, we wouldn't want to write all of this stuff every time we wanted to add a motor to our program, right? If our robot has 8 motors or 10 motors, it doesn't make sense to literally like copy and paste this amount of code over and over again because we have like 10 different motors, right? We want to be able to write it once and have a way that in our program we can just make duplicates for us without actually having to like have different places in the text to do it. Because if we had to do it with copy and paste and we were actually just copy and pasting the text, if we made a change or we found a bug that we were trying to fix, we might only fix it in 1 or 2 of the 10 places, and that wouldn't work well. It would be really easy to have a bunch of errors in our code. We really wouldn't want that. So the class allows us to let our let our program do the duplication for us. So it's kind of like, you can kind of think of it like an advanced variable. They're called objects in Java. And so we can create an instance of a class, and so then we can have multiple of these classes, and we can use all the stuff inside of them for each instance. So if we change some of these variable values, right? So say we change the speed values. So maybe I want M1, we want this motor to not be doing anything, so I'm going to assign it 0. And I can leave M2 going -1. When I execute, it'll show me M1's speed is 0 and M2's speed is -1, but we only have defined a single speed variable, right? We only did this double speed equals 0 thing once, but we have a method that allows us to set the speed, and speed here, because it's inside this class, is specific to which one of these motors that we're talking about. So M1, which is kind of like this looks kind of like how you do variable assignment, right? So we have this motor here instead of like int or double, because that's the name of the class. So we have motor down here. So we're saying we're going to make a motor. We're going to name it M1. We're going to assign it to be a new motor. So we have this new keyword that gives us a new instance of the class. And then because when you make new, we have this method right here. This is a kind of a special method. It is called a constructor. So it actually allows the program to build a whole new version of this class. So once we've run this new motor, we tell it what, in this case, kind of what port it's on is what we're asking for, what channel it's on. In the robot, that's kind of like just how it knows where the actual hardware is, where to actually talk to that motor. It's going to, once we have this and we do new motor and it runs that, it now has a channel and a speed for this M1. It also has these methods that are all associated specifically to M1. So we can modify things in here. We can set the speed, we can get the speed, and we'll always be getting the one we want from M1. The important thing is that you do have to be referencing a specific instance. So we have to talk about which one we want. We have to tell it, do we want M1 or M2? If we just tell it set speed, we just tell it set speed to 0, it doesn't know what that means because we didn't give it which instance of this class we're talking about. So if we execute that, it's not going to work and we're going to get this error. Method set speed, it can't find that symbol because it doesn't understand because we didn't tell it what class it is. So you kind of have to give it enough information to get to the right method. So we can add that M1 back, and it'll do what we were actually asking for. Yeah, so each object is a new instance of the class. They all keep their own values. That's one of the biggest things to understand. So on our robot, our motors will have classes, and we'll have instances of those. The various sensors we use, the game pads we use, a lot of the different things where you can imagine we'll have multiple. They'll all have classes. A lot of times, even if we only have one of something, we'll still build it up as a class. It's just an easy way to organize stuff. It's an easy way to make sure we have a specific method we want, and we're calling the exact right thing we need. So the classes are super important as we get into next week when we're starting to kind of really get into a lot more of what happens with the robot programming. You'll see how much we use this class thing all throughout Java, and it's one of the key to kind of points of what Java does a little bit differently than some of the other programming languages. Not all of them, but some of them. Yeah, so then object.method. So this M1 is the objects, the instance of a class, and we do dot its method, so dot set speed to be able to actually access it. Each class does get a unique name. That's important, so we want to make sure we couldn't like have another, if we, in the same file, if we had class motor again down here, it wouldn't understand how to differentiate it, so it doesn't let that work. The constructor method, which I talked about a little bit earlier, is the specific method, it does have to have the same name as the class. That is one of the things to understand. So this is the class is motor, the constructor is motor. Those have to be the same name. This does not have to be declared void, and you also don't have to declare a return type at all. So that's one of the ways to identify that it's the constructor. We don't have this int, double, or void here, because what it returns is the instance of the class, right? And it knows that because it already has this name. So we know that when you call this with the new thing in front of it, when you do new motor 0, it's assigning M1 to be that new instance of that motor class. Classes have its own methods, like we already talked about. I didn't talk about getter and what etc. So these are kind of common a lot of times, where you just have a method that all it does is get a specific value. So instead of just being able to like access this integer channel directly and like asking for its value, instead we use the method. So we'll do m1.getChannel here and m2.getChannel. And that lets us, all it does is return channel. So they're super simple. They're not hard to write, but we use these a lot all throughout our code to get information about some of the variables that are inside of our classes. We have a similar thing down here called a setter method, where all it does is it takes a value in and it sets the variable inside of it to that method. So set speed double s is going to take in a double value and assign it to our speed variable inside of it, like we did up here when we changed this to 0 and from 1, and we saw that we could then check the speed with get speed, and we could see our change was done. And both of these happen quite a lot inside of a lot of our different classes in the robot. It makes them a little bit longer, but it does make, it kind of just makes the flow of the program look a little bit easier instead of trying to access all those variables directly. You will also see a lot more complicated methods inside the classes as well. Okay, that about wraps up our intro to Java. So from here, we're going to look at a couple of things about how to like actually install WPI lib. I'm going to go and stop this recording.